I'm not representing all amphibians in the Banksia woodlands. I'm representing this very unusual and special beast here, the turtle frog, and I'm really interested in its sex life, so that's really what you're going to hear about today. This is a Banksia woodland specialist because it eats termites that basically eat the Banksias and the trees and the roots of the Banksias. So it's only really very closely associated with Banksia woodlands and in these sandy soils. So the first point I want to make is that courtship is an amazingly variable exercise. So some of you might regurgitate the chicken bone to impress your mate. Of course, other things are, you might make a beautiful song, an impressive show of feathers. There's many ways to do courtship, to attract a mate, but the really consistent thing that happens after courtship is sex. There's usually not much of a gap between the courtship event and the actual mating. And this is where turtle frogs are really interesting because we think this species might be doing something quite different. Beautiful animal here. This is a male that's come up after a thunderstorm in the spring and is calling to females. So this is what the courtship event looks like for a turtle frog. So here we have the male up here calling to a female that's approaching him. So she follows him around for maybe sort of a couple of minutes. Then he burrows down, does a different courtship call. She burrows down after him, and then there's nothing left on the sand. You've got to basically be there to see this if you're going to know where they've actually gone and bury themselves. So this happens in late spring after rain events, so usually up until middle of December. This is Dale Roberts. He did a lot of the earlier work on turtle frogs. He went out and looked at lots of these courtship events and then dug big holes underneath the site the next day or the day afterwards. He never found anything. Sometimes he found the frogs. He didn't find any evidence of mating. But he did find this if he did it in autumn. So it seemed to be there's this delay. They do this courtship in the springtime, and the only time that Dale found embryos was in the autumn. It sort of implied that they weren't actually mating straight away and that they were waiting for some reason. What we have here is a guild of terrestrial breeders. They don't have an aquatic phase of the life cycle. And West Australia, the southwest in particular, has 3 species which we call direct developing. And the turtle frog is one of these. It hatches from the egg capsule as a miniature version of the adult. So most animals, or most vertebrates, are what we call associated breeders. This means that they basically mating when their gametes are at their maximum maturity, so when the sperm is most abundant and the ovaries are most ripe. What we know from Dale Roberts' work on turtle frogs is that they do this calling, this courtship behaviour at this time of year in the spring, and they sometimes did it here in February, and he only ever found embryos here. So how we went about it was we looked at how the changes in the testosterone concentrations and other reproductive hormones, how they changed seasonally, how the gonads matured over time, and we looked to see whether there was any evidence that females were able to store sperm internally. Very hard to find them when we think they might be mating because they're actually up to 2 metres underground. So we did it with this artificial arena here. This is a stormwater pipe which has been cut and then resealed, and then we buried them flush in a Banksia woodland and sealed it with some tin here. And then we waited for a rain event like this. So this is what the radar looks like when the turtle frogs are coming up. This is a thunderstorm back in 2007 in December. So the frogs will come up en masse on those sorts of nights, and here's the arena looking down, top down. You can see lots of little turtle frogs in there. So we put about 40 frogs in there, and we've actually plastered any gaps between these pipes so they can only bury into a pipe. And they behaved quite normally in these enclosures. You go out on subsequent nights after a bit of rain, and the male will be up there courting, and the females will be out listening to different males. So that was encouraging. And so then 80 days later, when we thought would be normally the time we'd expect them to be mating, we dismantled this enclosure. And so we pulled out each of these pipes and we could slit them down the hinge and then open them up like this, and search from the top right down to the bottom to see if we could find frogs and see if we could find any evidence of mating. I should say that there's fly wire mesh at the bottom to stop them getting out the bottom. Okay, and so this is what we found. I bet you can't see anything there, but this is actually, there's some very small eggs, and this is a female here and a male here. So we found evidence of mating, which was really exciting. So we'd actually dug this up on pretty well the right time of year. The most striking pattern is that both sexes here have a very big spike in testosterone in the courting period, but they had very low testosterone around mating, which is less common. But we were trying to see whether the females were really ready to lay eggs in that courtship event. So this is what a large egg looks like under a microscope. This is a small egg here. You can see when they're non-reproductive, they've got these tiny eggs and they've also got these broken down egg cells called atretic cells. But when they're courting, they've got all three types, so it looks like they're more or less ready to go. And they're also, the gravid ones look much the same. So there were no real clear differences in the sort of size and the composition of the ovaries between a courting and a mating female. But what did happen is that females continued to build the egg sizes, so the eggs did get bigger over that summer period when they potentially were paired together. The oviduct also had some striking changes. Oviduct maturity was much more pronounced in the mating time of year in the autumn. Now, as for the males, they had complementary patterns. So this is looking at their sperm abundance, a lot more during the mating period than in the courting period. Also concentrations of sperm, there's also a lot more sperm when they're mating rather than courting. So it looks like males in the courtship period really they do have sperm that are viable, but they're not certainly as viable as they are later on. And you can see that swimming speed's much better in the mating group. So suggesting that that's really the time that they're most primed to be active. So really what it looks like is we've got something new. Frogs are courting and pairing in November and December and then burrowing together without mating, and the frogs mate and the female produces eggs in around February. So that's pretty unusual behaviour. So their breeding is associated, so as in the breeding events are associated with these hormonal changes, but their behaviour's separated. They're doing courtship and mating at quite different times of year. So the question for the talk is, why pair when the passion's not there? Why are they doing this? Seems to be a bit of a waste of time. This is a sort of chart that shows the rainfall change at the study site. So obviously very little rain annually in the summer, lots of rain in the winter. The young basically need to come out about here, which is when they can frequently come up to the surface and forage and grow. So they take about 2 months to develop underground because it's pretty warm, about 22 degrees underground, which really means the mating needs to be timed about here. But in order to do that, the males and females need to come to the surface to find each other. And they're just so often that there's very little rain over this period that it seems to have been adaptive, that they've got into the habit of pairing earlier and then just sitting out underground together and delaying mating. But we don't yet know what the cue is that turns this behaviour on. This seems to be unique to West Australian frogs. It's probably likely that the turtle frog and the two sandhill frogs have this dissociated kind of reproduction. And these guys probably have done this quite some time ago, perhaps as a response to the aridification of southwestern WA. And it seems to be that waiting before mating is allowing seasonal breeding in an unpredictable environment.